Hello class, I'm here to talk about the last distribution on chapter 5. We have gone the uniform distribution. I have assigned quite a few problems, and now we're going to be talking about the exponential distribution. And on chapter 6, we're going to be jumping to the normal distribution or the standard normal distribution. In chapter 7, 8, they will build upon all that. Actually, all the remaining chapters are going to be mostly building upon chapter 6. So for the exponential distribution, just like I did with the other ones on chapter 4, I don't expect for you to remember all these formulas right here. Okay, so that they're giving to you. So I put everything on an Excel. And one thing, the exponential distribution is concerned with the amount of time until some specific event occurs. In the Poisson distribution, if you remember, if you ask what is the difference, is that this Poisson probability distribution is interest on the number of events occurring in a fixed interval of time. On the exponential is the other way around. You're concerned with the amount of time until a specific event occurs. Okay, I have put in here just like the chapter 4 a few things for you to remember so you don't have to memorize anything. Let's just don't forget that this actually is going to be the same as lambda, which is this symbol over here. So let's close. So every time you see a m, just replace by lambda, which I don't want to spend too much time on it, but just let's put it over here. Okay, and then so when you see the m, just think lambda. And do some problems and see how we can solve some of it. So let me see. Problem start right here. Problem 83, for example, which starts the exponential distribution. It tells you, let me copy over here. Copy it on this side over here. Okay, Q. What is the mean? So let me put it here, insert, which I just can put U, but so my mean in this problem we know is equals to 8 minutes. Okay, so how do we determine the lambda? The lambda is going to be 1 divided by my mean, so equals to 1 divided by 8. So that's my lambda value. Okay, and the last thing I need, if I tell you what is the standard deviation for this problem, the standard deviation is always going to be the equals the mean, so the standard deviation would also be 0.125. You don't have to put all the decimals. You can do as you wish. Okay, and then it tells you if you're being asked a value x less or equals, like right here, less than 9 minutes, you're going to be using this formula. If you're asked a value that is more than, then you're going to be using this one, x more than. But if you are asking a value, which it's, I believe, in other problems, that is asking you in between, for example, in between 7 and 9 minutes. Oh, it's right here. Then you would do, you use this formula over here. So let's go ahead and do it using this formulas, and then I'm just gonna go ahead and replace by the Excel formulas to see how faster that goes. Okay, so for A is asking you to define the random variable x. So what are you interested in? Suppose that the length of a long distance phone call measuring minutes is known. So okay, so your x is equals to the length of long distance phone calls measured in minutes. So when I tell you if x, I want to know x equals 9, that's what it means. You're looking for the length. This would be the length of the long distance phone calls measured in minutes. Okay, so B, is it a continuous or discrete? Well, you are determining the amount of time, so that would be a continuous. Okay, so X is going to be a continuous variable. Okay, C, well, what is my mean? I actually already calculated for you over here. So my mean is this value. And then D, no, and then D is the standard deviation, which I already also calculated for you over here. Because remember that I said that your mean is the same as your standard deviation. There you go. Okay, E, we don't need to do the graphs. The graphs helps you in the meaning when we get also to normal distribution, the standard normal distribution. It helps you to determine the shaded areas. So when you're asking for values in between, high or less, it gives you an idea of what you should expect on your probability. So let's just skip the graph. Okay, let's go to F. So find the probability that a phone call lasts less than 9 minutes. So if I look for the formula over here, so less than 5 minutes would be this formula. So let's go ahead and replace now for actual values. 1 minus the exponent of minus lambda times x. Sounds confusing, right? But remember, your lambda, you already determined it's right here, okay? Your mean, in this case, your x, you're going to replace by the value is asking you over here on the problem, okay? And this is going to be part of the formula, so you're going to see how easy that is. Do equals to, let me do a parenthesis so he knows that is 1 minus the whole exponent, so equals to, and then start typing exponent. There you go. It says returns exponent raised to the power of a given number. Okay, so exponent of minus my value over here times 9. And here you go. That would be your probability would be 67, about 68% or 0.6753. It depends how many digits you would like to include in here. Let's put decimals. So let's put 4. Okay, G now. It says find the probability that a phone call lasts more than 9 minutes. Let's take a look in here. More than 9 minutes. So this is the formula over here. Do equals exponent and then minus my value over here times how much is asking now, more than 9. So enter, then we have a 32.47% or about 32% or 0.3247. Your the solution for your book actually is incorrect. This would be the correct solution. And then H, find the probability that a phone call lasts between 7 and 9. Between is over here. So we're going to use this formula over here. Okay, so between 7 and 9. Let's make this bigger. So what we do is the exponent of a negative mean times my first x, which is 7, right? Minus the exponent of my negative mean times my b, which in this case it's 9. So if you look at it, you would read like this. What is it? 7 and 9, right? So my x and then 9, which, they replace it here a and b. That's what it means, okay? So we're looking for this distribution. So it's going to be equals to the exponent of minus right here mean times, and then a, which is 7, minus, I'm just following this formula over here, and now again the exponent of minus this value times, what is my second one, 9. And why do I put all this parentheses? Because I'm here, I'm telling it, oh, I'm missing something here. I'm telling Excel calculate this and then calculate this. Don't put it all together because it's like the pandas rule that I went over before. So do enter. That sound means I probably miss a parenthesis somewhere. There we go. It's telling me I needed to close it with 2 parentheses to do the whole formula. So it corrected for me. So the value would be 0.0922 or about 9.22%. This is not 90. This is 9. Okay. So you would, okay, here you go. And if 25 phone calls are made one after another, on average, what would you expect the total to be? Well, to calculate this expected value over here, all you need to do, you're gonna get the total, which is 25, and multiply, right? So if you get an average of 8 minutes and right here, suppose that the land long distance measured minutes known to have an exponential 8 minutes. So we have 25 phone calls times 8 minutes. So then it would be about 200 minutes. Let me take this decimals. Okay, so you can say on average, um, one should expect the total to be 200 minutes, or so you can do 1 hour 60 minutes, so you have 3 hours and uh, 20 minutes. Okay, right here, because each hour equals 60 minutes, so 3 hours is 180 plus the 20, that's 200. Okay, and then you say, okay, you went over all that. How do I use these formulas? Well, let's try to use them. Find the probability that a phone call lasts less than 9 minutes. So you're gonna do equals to exponential distribution of less than 9. So everything up to 9. So 9, and then 1 divided by 8 from up here. Remember, from up here we did 1 divided by 8, which is my lambda, and then we're gonna do true because we want everything up to 9. Okay, so all this that I did over here, all this formula over here, it's gonna be as easy as using this formula over here. Okay, so now for the other one, now we're looking for less more than 9 minutes, right? So this is less than, more than. Okay, so all we have to do is to do equals to 1 minus the difference. So which would be 3247. Find the probability that a phone call lasts between 7 and 9. So we're going to do the exponential distribution, um, 7, correct? My lambda is going to be 1/8. And then it's true because all the way to 7. But actually, you got to do the other way around because you're doing 7 and 9. So you're going to be really just doing this interval. So you got to subtract one from the other. So let's go ahead and do 9 first, or just put a negative sign in front, minus the exponential distribution of 7. My lambda is going to be 1/8, or 0.125, and then it's true because you want a cumulative value, and that's going to be exact the same value over here. See, instead of doing all this, which you could because it's easier for you to see what's going on, you can also just use these formulas. You're just going to have to really be careful when you're using a cumulative value and when you're not. And when you're subtracting, you're subtracting the smaller from the higher. Otherwise, you're going to get a negative value. And then you would be done with problem 83, which I'm actually assigning for your homework. Thank you.